Hi everyone. Okay, now we're moving on to the next topic, which is volcanoes. We've already talked about earthquakes, so this is sort of the destruction part of the class. All right, so volcanoes basically are just hot molten material inside the earth. Lava that forms outside, or magma that, hot molten material that forms outside a volcano is called lava. That forms the extrusive rocks that we've talked about a couple of weeks ago. Hot molten material that forms inside the earth is called magma, and they form intrusive igneous rocks like granites. All right, so again, if you can, please try and write down these notes, include them in a Google Doc, send them to me so that I can see that you're doing the work. Let's talk about gases that come out of volcanoes, and we briefly mentioned this when we were talking about the atmosphere unit. So the main gases that come out are carbon dioxide, hydrogen sulfide, ammonia, H2O in the form of high pressure steam, the explosive gas methane, and cyanide, a deadly poison. This is why not many organisms like living around volcanoes. It's pretty dangerous to live there, not just because of the magma, but because of the gases that are produced. And if you've seen any volcano videos, and I'm sure you have, you've seen explosions coming out of these. That's the methane gas that's exploding. Notice no oxygen comes from volcanoes. It's just so hot that any oxygen that's present in there will form carbon dioxide or sulfide gases. There's a variety of different material that's produced and shot out of a volcano, and it's basically classified on how big it is. So if you have really small material about the consistency of flour, less than a quarter millimeter in diameter, it's called dust. If it's about the size of rice grains, anywhere between a quarter to 5 millimeters, that's called ash. If you get up to the size of golf balls, those are called cinders. And anything larger than golf ball size are called volcanic bombs. These things don't explode. Think of them like cannonballs as they're fired out, because that's really a good analogy with how that works in a volcano. Now, there are four different types of volcanoes. Some of the most famous ones are called shield volcanoes. We see these at Hawaii. They're very wide at the base and not very tall. They produce only lava, and they are the least violent of the four types of volcanoes. Then there are cinder cones that are narrow at the base and they're tall. For example, the Mexican volcanoes. They produce just rock particles. I got a chance to go to a cinder cone when I was in graduate school. It was in southwest part of the U.S. And it was weird. We pulled in, I remember, to this parking lot. We pitched our tents. I got up in the morning and the ground felt really weird. It was like we were sleeping on black popcorn, is the way that I can describe it. And that's what cinder is like as it's shot out of a volcano. Then there are composite volcanoes, which are a combination of rock and lava. Mount St. Helens is a good example of this. And then there are the calderas. These are the cauldron-shaped volcanoes of the Greek islands. They're composed of rock material. These are the most explosive. What happens is that water will go inside the volcanic crater, hit the hot magma, become high pressure steam, and literally explode outward. And here's some pictures of volcanoes that you can see. So there's shield volcanoes that are very wide at the base, not very tall. Then there are cinder cones, like think of an ice cream cone upside down. And then there's the composite volcanoes, like Mount St. Helens. And then lastly are the calderas, or the bowl-shaped volcanoes. So why is it that some volcanoes are really violent and some of them are very gentle? Well, that's a good question. And there's a variety of factors, I think, that controls the violence with which a volcano will erupt. The first is gas pressure. So think of a volcano like a can of soda. You know, you pull the top and you this rapid escape of carbon dioxide gas. Same thing happens inside a volcano. It's actually a release of this pressure that causes the eruption. Higher the gas pressure, the more violent the eruption. Then there are vents. We know that there are holes in the side of the volcano. The more vents you have, the lower the gas pressure is going to be, so the less violent the eruption will be. Then there's viscosity. We all know that liquids flow at different rates, okay? Some liquids are like water. They just flow very quickly and easily. Other liquids are like molasses. They take a while to flow over a surface. So viscosity is the resistance to flow. A molasses type of magma would flow very slowly. And it turns out that it's the sticky, highly viscous magmas that are the most dangerous. These are the ones that form plugs in the crater. The gas pressure builds up, and then boom, the volcano explodes violently. Composition. So how do we know, okay, what the viscosity is going to be like? Well, it turns out there's a really simple clue in igneous rocks. If you have a lot of light-colored quartz-rich magmas, those tend to have high viscosity and they tend to be the most explosive. On the other hand, if you have a lot of dark-colored minerals in them, or olivine, these tend to have low viscosities and they tend to be the least dangerous. And I think this is really cool. If you've ever been to the peaks of Otter, was the rock there light or dark colored? Those were ancient volcanoes, and they're actually mostly light colored. So you wouldn't have been around a billion. You would not have wanted to have been around a billion years ago when those were going off. They were very explosive. On the other hand, the ancient volcanoes around Rocky Mount of Bald Knob and Grassy Hill, yeah, those were ancient volcanoes, had very low viscosity as a result. When they went off about 600 million years ago, they weren't that dangerous, okay, towards the later episodes of those eruptions. So the question is, what effect does temperature have inside the magma chamber? Okay, if I increase the temperature, is that going to make the eruption more or less violent? Think about it for a minute and then I'll tell you the answer. If you said the higher the temperature, the more gentle the eruption, you'd be correct. It turns out that as you increase the temperature, the viscosity goes down. So these lavas flow more easily. On the other hand, if you have lower temperatures, you get more sticky lavas, and these tend to be associated with more extreme violent eruptions. And that's it for that topic.